As we've seen, Java makes it very easy to extend classes and override methods. In fact, by default, all classes can be extended, and when you inherit from a class, you have the option of using the methods as they were written in the base class or overriding them. But sometimes that may not be what you want. Maybe you want to put more controls on that. And it turns out that a class can change these defaults. It can control whether it's allowed to be extended and how overriding methods works. One way it does that is using what's called final. Final allows us to prevent inheriting of an entire class or the overriding of certain methods. Let's take a look. Let's say we have our class here, our passenger class that we've seen before. But let's say we've decided that, we don't want to allow any specialization of the passenger class. We don't want to allow anyone to extend this class. Well, all we have to do is take the passenger class and mark it as final. By marking it as final, simply put, you cannot inherit from it anymore. You're not allowed to extend that class. One thing to note, though, is that the order of public and final here doesn't matter. If we want to, we can switch the order of those. It still has the exact same effect. So marking a class as final is a very simple thing. It simply blocks extending that class. But very commonly what we want to do is allow a class to be inherited from, but have certain methods we do not want to allow them to change. Let's take a look at our cargo flight class here. Let's say we want to go ahead and allow people to inherit from cargo flight and specialize cargo flight, but we want to make sure that they don't change the way that adding a package works. So what we can do is take our add one package method and just mark that method as final. By marking the method as final, now you can inherit from cargo flight, but you cannot override add one package. You can go ahead and override other methods that might be in the class if you have access to them, but in the case of cargo flight, there are no other methods that you can override because add one package is final and has cargo space and handle no space are both private, so a deriving class couldn't change those. Now, methods that are inherited from flight could be overridden. Right? So we're just very selectively blocking what can be overridden. In the case of final, you'll generally either mark the class as final or an individual method as final. Because once a class is final, there's no reason to mark individual methods as final because you can't override anything if you can't inherit from it. So final is a method or class situation. Now there may be another situation where instead of trying to prevent inheritance, you want to go ahead and require inheritance. Right? And that's where abstract comes in. Abstract allows you to require that a class be inherited and require that a particular method be overridden. Right? Let's see what that looks like. Let's create a new class here. We'll call it pilot. So we'll have our pilot class, and we'll go ahead and a pilot can fly a flight. So we'll have a current flight field. And we'll add a method called fly that accepts that flight. And what we'll say is that, well, if the pilot can accept that flight, we'll go ahead and assign the flight to current flight. If they can't, we'll go ahead and just handle that case if they can't accept it. For handle can't accept, we'll just do what we've been kind of doing is simply printing out a message. But when it comes down to the idea of whether the pilot can accept the flight or not, that's going to depend on what kind of pilot it is. And we want to leave that to the classes that inherit from pilot. So what we'll do is we'll go ahead and mark something as public, and we're going to say now abstract. And then we provide our standard method signature. Right? So it's a public method called canAccept, returns a Boolean. But by saying it's abstract, we're saying that we're not going to provide an implementation. Now, since we're not going to provide an implementation, what we do is that rather than providing a method body, we just put a semicolon at the end. So we're simply saying that the class pilot has a method called canAccept. We don't know what the implementation of that method is, but it has that method. And what that allows us to do is use canAccept in other methods in the class, like in this case, the fly method. Now, once you mark a method as abstract, that means the entire class must be abstract. So we'll go ahead and mark the class as abstract as well. So when it comes to abstract, if you have an abstract method, you have to mark the class as abstract. It's possible to mark a class as abstract and have no abstract methods, but that's not very common. Normally you'll have one or more abstract methods in any abstract class. So now the way we work with this, right, let's go ahead and define a pilot we'll call our cargo only pilot. That extends our pilot class. Because it extends our pilot class, it has to provide an implementation for canAccept. So we'll go ahead and set that up. We'll go ahead and use the override annotation. And what we'll say inside of here is that a cargo only pilot is not allowed to have passengers. So we'll take the flight called getPassengers, and we only return true for canAccept if there are no passengers at all. Now we have another class called full licensed pilot, and he's kind of our super pilot, or he's allowed to fly any flight. So what override can accept for him, go ahead and mark it with the override annotation, and he's simply going to return true all the time, saying he's allowed to fly any flight. Right, so it allowed us to define basic characteristics and behaviors in the pilot class, but then require specific specializations in any derived class.